So our project goals are still the same as before. We are going to move 4 Zumy robots to the designated formations, including square, a vertical line, horizontal line, triangle, and diamond shape. So after the formation of Zumys is formed, we'll move Zumys in unison while maintaining its formation.
So currently we have good localization and we're able to find each Zumy relatively well. And using this, we've been able to get basic formations using 3 Zumys, as you'll see in the following video. We've also been working on using an A-star and model predictive control approach in contrast to the position feedback controller, so that we have better control for the Zumy formation. In addition, we've developed a state machine model to look at the input-output behavior between the Zumy and the computer. That includes potential connection failures. And currently, we are working on a collision avoidance algorithm so that the Zumys will not hit each other while getting into formation. And we're trying to adapt the A-star and MPC approach for the Zumy formation problem.
So the relevance of our project to the course is as following. Model behavior governed by the state machines. The interactions between Zumys and computers are modeled by the state machines such that robustness to the signal loss and the connection failure can be developed. Also, there are a lot of control theories used in this project. Currently, we are using position feedback method, but MPC method approach will be used. Also, we want to develop an accessor to allow for Zumy formation behavior.
So using position feedback control, we've noticed that the Zumys don't quickly get to the goal position. To solve this, we would use our A-star MPC approach to have quicker convergence. In addition, our collision avoidance algorithm is still in progress. Our idea is to use a simple model of the robot motion and look for intersection in the paths, but our ultimate goal is to use A-star with dynamic constraints, so we have collision-free paths. And finally, we're looking at the usage of accessors, and this may be difficult due to the volume of Python code and the level of configuration involved in getting the Zumys to work, but we will approach this as a stretch goal for our project.
Our first member, Nick, has worked primarily on developing our state machine as well as our collision avoidance software, and in the future will continue to work and improve on both of those. Our second member, VJ, has worked primarily on our lower level feedback control as well as our collision avoidance software, and in the future we'll be working on investigating the use of accessors, developing a GUI, and time permitting, seeing if we can incorporate a Wiimote for user input. Our third member, Kiet, has worked primarily on our A-star and model predictive control approach for our Zumy path control, and will continue to work on that in the future. And our fourth and final member, Haoyu, has worked primarily on localizing the Zumys using AR tags, and in the future we'll be ensuring that all of our formations are tested and are working properly, and also hammering out the final demo preparation.
Yes.